My name is Alina Zharikova. I'm a business development manager, and today I will be moderating the webinar. Next to me is sitting Philip Stumshais, our software engineer and today's webinar speaker. While we're waiting for some people to join us, I would like to tell you a few words about RULA Technologies. RULA Technologies is a European manufacturer of test and measurement instruments. The company is headquartered in Riga, Latvia. We implement customized solutions for automotive, aerospace, research, and other industries, and we mainly manufacture vibration control and data acquisitions, power amplifiers, and software. For all our customers and partners, we offer free updates, lifetime compatibility, installation and training, versatile equipment, tailor-made solutions, free online education, agile support 24/7, and flexible warranty. Now a few words about technical sides of the webinar. As usual, you can ask your questions through the comments box, or you can use a raise your hand tool to let us know if you can't hear us or can't see the presentation, or you would like to ask us a question. I think everything is clear, and without further ado, I can give the floor to our today's speaker, Philip Stumshais. Philips, you're welcome.
Hello everyone. In this webinar, we're going to talk about vibration testing and standards in railway industry. We will discuss most common test types, standards, their specifications, types of setups, and I hope this webinar will be interesting and worthwhile. So, first of all, why do we need vibration testing in railway industry? Train production is a complicated process which includes a lot of testing, research, experiments, and so on. And while working on a train part, for example, a train carriage or a train head, we need to take into account all electronics, mechanics, and materials. Every part must be developed in a such way it can be used for a long time period and it's able to withstand long time vibration impacts. And a lot of attention is usually paid to materials like metal parts for crate mounting, bogie mounting, and so on. It's very important to select proper materials for the frame and body or for the train carriage. Going through all these steps, engineers need to perform vibration tests and model analysis. And here in the slide, you see most common application spheres in railway industry, like fixture tests, material testing, which includes model analysis, mechanical vibration testing, durability analysis, and structural design. And of course, such tests need to simulate natural environmental conditions like real life road shaking and so on. And of course, there are a few factors for testing. During the development process, we need to select proper materials, check their strength, durability. Some of the parts can be fabricated multiple times, and we need to check how they will work under some vibrational conditions. And of course, we need to perform environmental checks and pay a lot of attention to structural design. And there are three main ways of vibration testing in railway industry. The first one is regular single shaker testing. It's used for single static parts like trunks, mounting, body parts, electronics. Multi-shaker testing is used for moving parts like rolling stock. And of course, we need to have an ability to apply model analysis for structural design. It can be applied to single parts or a full train with a lot of sensors, and that way we can check the full production of the train and its parts. And now let's talk a little bit more about the standards. The first one is IEC 61373, which certifies the equipment related to the railway industry and railway rolling stock. So it guarantees resistance to shocks and vibrations. And this standard has three different categories, which represent testing different parts, and these parts are separated by their train mounting. The first one is crate mounting parts, the second one is bogie mounting parts, and the third one is axle mounting parts. Also, we need ISO 16750, the first part, and ISO 103 and 26, also the first part. The first standard is used for environmental testing of electronics, and the second one is used for seats testing in the transport. Also, we can use ASTM D4169. It's mainly used in shipping and transportation tests, but this standard has random profiles which can simulate train shaking, and we will run such tests today. And of course, MIL STD 810 is widely used because it has great shock impact profiles and environmental tests. And I need to mention that this standard, although it's military, but it's mainly used in civil sphere now, because it has great points on electronics testing, environmental conditions, and nowadays it's being used mainly everywhere. As for the tests, there are three main test types: sign, shock, and random. And of course, we have a multi-shaker versions of these tests, but I think using this standard test pack, you can cover all you need during the test run. And I think now we can switch to our software. And I'll turn on the camera. Here you see that we're using our regular setup. We have our shaker. It has an extended shaker stable, and we have a train model mounted on it, and it's fixed. There is one accelerometer in the center of the shaker stable, and another accelerometer is mounted here on the train. We're using regular ROC21 controller and RLA 200 amplifier. Our sensors have sensitivity of 10 millivolts per G. And here we have our software. And our first step is to create sensor configuration. Let's go to configuration tab, go to channels, and let's add a configuration. Its name will be webinar test. Here we enter the sensitivity of the first and the second channel, and we don't need settings for the third and the fourth one. Their type is IEP, so let's apply it. Firstly, we will run random test. It will be created by template. So we press here on ruler icon. And here we have create test based on test template. And we're using ASTM random rail level 3 here. Press OK. And here you see the default profile from this standard. And after that, let's go to limits, check our shaker. And I think we won't run from such low frequencies. We will move them a bit. And here you see that we have a rather low level. We'll recalculate it. But before, we need to select our channels. Here in the channels tab, we select webinar test configuration and disable the third and the fourth channel. After that, let's apply the settings. Here you see our displacement is now in green zone. It won't cause any damage to our selected shaker. And after that, here I want to have error mass of 1G, so I enter 1 and press recalculate. Here we have our profile based on ASTM D4169 standard. It's a rail. And after that, we press OK. And I need to set up the gain on the amplifier. Let's double check the settings. So here we have a 3-hour duration. It's too big for us. Let's set it as 1 minute. And I think now we're ready to start the test. We're starting up now. And I need to say that this test is really loud, so I think you will hear it. Yeah, you see that we are running. I think you can see the vibrations. And our startup is complete. Let's create more graphs. And you see that on the second channel, which is blue, we have spectrum increase here. And I think maybe we will have a resonance if we go and turn levels up. So we finished our test. It was quite loud. And now I think we can switch to the next test. It will be shock, and it will be based on MIL STD standard. So I press create test based on template. And here we have MIL STD 810G and H. Let's create this shock test, and we will use half sine. Let's set a lower amplitude will be 1G, but I think if we will need, we will manually change the amplitude. And let's make 50 shocks and set manual mode. After that, we go to limits, check the shaker, and you see that abort and tolerance are calculated according to this standard automatically. You will see it on the graph. After that, in channels, we select webinar test and disable these two channels. Here you see that these lines above and below the task level are calculated according to the standard. And now let's start the test. Now we can perform the shocks. I think we can set a higher level. Let's set it back to 2G by entering to 100% here. So like this, let's create another graph. So you see that on the first channel we have our task level on the peak acceleration graph. Here we're running about 2G level, and the sensor on the top of the train has something like 7 or 8G amplitude. And now I think let's start the test in automotive or automatic mode. Here we disable this button and we start to perform shocks in automatic mode. And let's create spectrum. Here you see that in frequencies above 100, the second sensor has a higher signal than the first one. And now the test is finished and we can switch to another test. It will be sine. We will create a simple profile, but here we will go from 100 Hertz to higher frequencies and maybe find some resonances. So we switch to sine. Let's create a new test. Here we enter 100 Hertz, 1G level. We will go up to 1000 Hertz, also 1G level. We will run profile. Here in the channels, we need to switch to our configuration, disable these channels, check the limits, and I think now we can try to run this test. So let's start. And you see that the second channel is increasing its amplitude. Here you see a peak. And it's a really noisy test. Let's add cursor. And here, I think about 230 Hertz, we have a resonance on the top of this strain. And maybe we will get another one. Because you see that the amplitude is increasing again. I think we can say that this point can be counted as a resonance. And another resonance. So it was a really noisy test, but you see that we found, I think, 3 resonances, and using sine, you can have a larger frequency range profile with, for example, amplitude increase. So you can find the resonances, and using another tool, which is called fatigue test and advanced sine. We had webinars about them. You can work with these resonances, try to check the durability of your testing object, and using this test set, you can cover mostly all your needs. And I think let's check the questions.
Yes, we have a few questions. So the first one is, do you have an option to perform multiple different tests in a row using single test run?
I think you may talk about the sequence of tests option. In that case, if you have this, you create a set of tests, for example, 2 sine tests, 2 randoms, after that shocks. They must have the same set of shaker and sensors. You configure these tests, and after that, in sequence of tests, you select them, press start, and in that case, these tests will run one after another. I think that's that option you mentioned.
I think so. So this test that we were running during the webinar, they could be used also with the sequence of tests.
Yes, because we have the same configuration, and I think maybe I'll show you an example. We press the sequence of tests. Let's create test. So here you see run the test command, cycles from the common tests, pause and wait for user command. So here I press browse. We had random. So I select the path to this file. I add shock, this one, and our sign test. After that, I can apply them, these settings. And if I press start, they will be running in a sequence like we have here in the test settings.
Well, I think it was clear. Another question. Can I have multiple channels for control in single shaker test and multi-shaker tests? I mean, multiple channels for one control loop.
Using multiple channels for single control loop is now available only in single shaker tests. Like, let's go to sign. I'll show you. Here in the channels, you can select other channels as control. And after that, you need to select control strategy. That means it's the way the resulting control signal will be calculated. Now, the default value is based on weight coefficients, so you enter coefficients for the channels, and after that, we calculate the average according to these coefficients. For example, if we know that the first channel is placed on the shakers table, it doesn't have any influences from our testing object, but the second channel is placed on, like here on the top of the train, it can have resonances. We know that the signal from the first channel is clearer than the signal from the second one. So we enter the higher coefficient value, and that means that the second channel is more clear and is going really close to our profile line. Also, we have maximum and minimum. That means that from all control channels, we select the value with this parameter maximum or minimum. As for multi-shaker tests, now we don't have an ability to have multiple control sensors for single loop, but I think in future releases we'll have this option. Now you can have only multiple axes and multiple control loops which are connected to this axis, and I think now it can cover all our customers' needs, but as for research and user requests, maybe in future we will have this option.
Thank you, Philips, for your extended answer, but there are also two questions more. So can I have test tab into Windows, like one with running test and another one previous test results, so I can compare the data?
I think if I'm right, in a next release, we will have an ability to open multiple test tabs. You can place them on different screens, and one of them will be selected to be the main instance of the software. You will be able to run the tests on that instance, and up to 9 other instances can be used to get the data from other tests. So you can in real time compare the data, copy the lines from the graphs, and compare them, create reports. And I think that's will be available in the next version.
And the last question is, do you have a modal hammer option for modal analysis?
Yeah, we have this option in modal analysis in SignalUp, and we have recording on our YouTube channel about this. So I think we can cover all your needs in model analysis, vibration tests, and tools for research and data analysis. So yes, we have this option.
We do.
So today we talked about vibration testing and its usage during the production steps in railway industry. We can apply all RULA devices and software for all types of testing, and if you're not sure if something is compatible or acceptable for such tests, you can write us an email. We will give a brief and detailed explanation for you, or maybe give you some support in the selection of the equipment. And we talked about the standards and made examples of vibration tests. So now you know how vibration tests are used in railway industry.
Yeah, thank you for being with us today, and thank you for being with us during 2024. We would like to congratulate you on the upcoming holidays and wish you accurate measurements and very interesting projects in the new year. So stay tuned. We will see you in the next